All right. So on on number 11. All right. Now I didn't give a diagram for this. All right. You can draw your own diagram. But it says that Tommy just bought a new fish to add to his fish tank. He wants to make sure the tank won't overflow. When he adds his fish, his tank has a base of 20 inches by 15 inches, and water level is 2 inches from the top. When he picks the fish up from the store, he brings in a cylindrical container with a radius of 3, and the water goes up 4 inches. When he adds the fish, what is the volume of the fish, and will the tank overflow? So there's 2 containers here. His container at home is what shape? Based on the dimensions given. Rectangular prism, right? Rectangular prism. And then he got the fish in a cylinder, right? So, 2 different containers, but what we need to figure out first is the volume of the fish. So, we can figure out the volume of the fish. We can figure out the volume of the fish by using the cylinder he picked the fish up in and find that volume first, right? So, first thing we're going to do is find volume of the fish. How are we going to find volume of the fish? Well, it tells us when he picks the fish up from the store, he brings a cylindrical container with a radius of 3. So first, since we're using a cylindrical container, we're going to use the volume formula for a cylindrical container, which is base area times height. The base of a cylinder is pi r squared. So, we got the radius is 3. What's the height that we need? No. The 4.
Oh, it went up by 4.
Again, in the cylindrical container, it tells us when they added the fish, the water level went up by 4. It doesn't matter what other parts they give us. The change in the water level, that's the displacement. So we just have to use that 4 for the height. We don't have to worry about anything else. Yeah, again, if you just use the displaced water's height as the height of your object, that's giving you the volume of the object that was put in. So again, the height that it was displaced by was 4, so that's what we're using. So now, 3 squared is 9. 4 times 9 is 36. So we got 36 pi. Now, I like leaving things as exact values as long as I can. Alright? Since the volume here is not the final part of this, I'm going to go ahead and leave it in pi for right now. Alright? So, this is in inches cubed, the volume of the fish right now. We already found the volume of the fish. The second part of this question, alright, so it said, what is the volume of fish and will the tank overflow? We need to know how much room is left in the tank at home. So again, this was the volume of the displaced water, which is equal to the volume of the fish. So that's what I just found. Now we need to find the volume that's left in the tank at home. So, volume left in tank. What shape is the tank at home? Rectangular prism. So, it's the same basic formula, but again, for the base, we're doing the 2 dimensions of the base. So, they gave us the 2 dimensions were 20 by 15. The height, then, what's the height of the space that's left? 2. Again, it says it's 2 inches from the top. So, left in tank. So, volume left in tank. How much water do you still have room for in the tank? You know. So again, on here, so again, we did the base area times the 2. That's for, again, the space that hasn't been taken up yet in that tank. So, multiply this out. 20 times 15 is, times 2 is Now, this is also in inches cubed. So, at this point, let's go ahead and change this one, because this doesn't have decimal or anything over here, so that's a nice number to work with. Let's go ahead and do this one. What'd you get?
113.04.
So now, this is the volume of the fish. This is the volume left in the tank. Will it overflow? No. The volume of the fish is much less than the volume that's left in the tank. So when we drop the fish in, the water will be fine. It won't overflow.
I have a question. So I did the 113.04 by finding the area of the base of the cylinder, and then I times it by 2, and then I times the other one. I did the 28 point whatever, 26 times 6, and then I just subtracted them from each other, and then I got 113.04.
Wait. You said you took...
So like, because remember it said it went up by 4.
Yeah.
So I started at 2, and then I found...
Oh, so you came up with 2 random values. Now, that's fine, but again, that's extra work, because again, if you're essentially finding the volume of the displaced water when you do that, right? Which is what we did here. The 4 is the height of the water that's been displaced. So again, we don't need to do the extra work. Here? So on here, it says the water level is 2 inches from the top, meaning that if I was to pour water in my tank, I have 2 inches, the water level from the top of the tank. Right? So I'm looking at how much room is left in the tank. How much more volume could it hold? So again, as long as the fish is less than what it could still hold, he fits in the tank. Now again, some of these questions are making you think a little bit. They're a little more FSA style question, I would say. Right? This is, taking a real world situation, applying the math, and then coming up with a, does it work? Does it fit? All right. Same thing with number 10, which is one of the other ones that you guys asked me to go over. Again, you will see a couple of these on your test. All right.
Wait, mister. But how do you know that the fish won't overflow?
Since this is less than the amount that's left.
But that's 2 inches from the top. So.
But again, it's a much bigger tank. Think about how big this is. 22 inches by 15 compared to a little cylinder that was only 3 inches in radius.
Alright.
It's okay. Anyway, now sorry, give me 1 second. So again, final answer for this, we had the volume of the fish was one of the answers, and no, tank will not overflow.
But I feel like it will overflow.
No, won't.
Because, mister, that's like 600 inches, the other one's like 2 inches, and then that's a lot more than 2 inches.
No. All right. Let's do some more. Let's see, number 10. Let's do that one next, because I think that's one of the other ones that a lot of you guys said. All right, on number 10, it says Kyle has an ice cream cone with a diameter. Why does this look like it's not focused? Is it just me, or does that not look focused? I don't know. It's as good as its skin. Any napkins? I don't, actually. All right. Number 10. Kyle has an ice cream cone with a diameter of 7 centimeters and a height of 14 centimeters. Again, what shape are we dealing with? cone. He puts a spherical scoop of ice cream on top of the cone. Assume that the ice cream scoop has a same diameter as the cone. If the ice cream melts, would the ice cream overflow the cone? Show your work to support your answer. Now,
How's it gonna work? You know how people be doing that extra. They put extra, so of course it's gonna overflow.
okay, so
This is not no real work. It's like fantasy.
again,
It's perfect.
what they want to know is, will the volume of that ice cream, could that be contained in the cone?
Yes, because the volume, if the volume of the sphere is less than the volume of the cone, it won't overflow.
All right, so the volume of the sphere is less than the volume of the cone, then it won't overflow. And then if the volume of the sphere is greater than that of the cone, it would overflow, right? So, on here, we have, doesn't matter which one you do first. We can do sphere first, I guess. For a sphere, what's our formula?
It's 4/3. Yeah. Cube.
All right. So, what is the radius of the sphere? 3.5. How do you know it was 3.5? Yeah. Divide by 2, and it said that the scoop of ice cream had the same diameter as the cone, right? So, we have all that formula. We just need to plug it in. Now, I would not recommend multiplying out pi, because in both these questions, you're going to be dealing with pi, right? So, you don't need to multiply out 3.14. That just gives you extra work. So, on here, if we multiply this out, what is, let's see, 3.5 times 3.5 times 4 divided by 3, 16.3. All right. Now, it doesn't even matter if you get like perfect values here to answer the final question. All right. Normally, would I leave my answer like that? Probably not. If I just asked for the volume, but we know what our volume is from this. Now we just gotta find the other one and see if it's either larger, smaller, or the same. So, volume of the cone. How do we find volume of a cone?
Oh, a volume of a cone, sir. You gotta do it's 1/3 base height. So you gotta find the base of the circle times the height of the.
And what's the base area of a circle?
It's
All right. So that's our formula. So, do we have all the parts to plug in? Do we have the radius? Huh? This one? What doesn't make sense? Why not?
Yeah. What happened to the height?
There's no height in a sphere. Did I, hold on, let me go back. I already erased it. Let me do it again. Did you get something different?
Yeah.
Alright, let me go back into my calculator here. 3.3. So this is what I'm doing, 3.3 times 3.3 times 3.3 times 4 divided by 3. Oh, I got 57.16 that time.
wait, for what? For the sphere?
Yeah.
I got like 100 and.
Alright. So it was 3.5 cubed, 3.5, 3.5, 3.5 times 4 divided by 3. That.
Wait. I don't know what's going on, sir. I got like. Oh wait, no, I'm lying, because that's before I multiplied it out all the way. All the way out, I got like 179.5 and 175.
Here. In case, let me also do times pi, in case some of you guys already multiplied it out.
That's how I did it. That's where I was. Yeah.
Alright.
We did it right.
So again, whether it's in terms of pi or not in terms of pi, I'm not sure.
Which one? 179.5?
I'm wondering if I did.
Um,
I might have done squared instead of cubed the first time or something. I'm not sure how I got that first number. So, shh.
oh wait, what? Wait, you're doing the cone or the sphere?
Hey, Brandon, can you flip off that first switch? The first turn around, right there.
It's one. Yeah, well, that's for the sphere. This is for the. Wait. This is for the sphere. This is for the cone.
Okay.
It should be 175.5.
79.5.
Yeah, I don't know because this is for the sphere. Yeah, this is for the sphere. 4/3.
Well, did you use pi or did you use 3.14?
I used 3.14. 4/3 times 3.14 times 3.5 cubed equals 4/3 times 134.62, which gets 175.50.
I mean,
7.16.
Sorry, at first my work is kind of small because I'm trying to cram, but
that's what I got. That's for the sphere.
For the sphere, I got it reversed though.
Now, let's try the cone and see what you get for that one. All right. Guys, for the cone. All right. 1/3 pi 3.5 squared. So we have 1/3 3.5. Oops. Clear. 3.5 times 3.5. That's 12.25 divided by 3.
Wait, what is that? When you get 3.5 squared?
Oops, sorry. I didn't write the height yet. What's the height?
14.
So I got 4.08 times 14, 57.16.
I would normally put every time we do that.
What is this trying to go all the way out?
No. That's right.
For gold? 179.
Wait.
I got one. Wait, Crow.
What's the height?
170. Then one of them is 175.5 because it's not equal. It can't be equal.
Yeah, that's.
It can't be equal?
No.
Why not?
What do you do?
One half of it is equal.
Wait 1 second. It's postponed. Our Friday is postponed.
Guardians of the Sphere.
Starting
I got 175.5.
All right, guys, look. Shh. All right, this is the correct answer. Both of them are the same. Will it overflow if they're exactly the same?
No. Well, I get the same.
No.
I don't know. I got 175.50 for the Sphere.
But however you do this problem, this is why it should have came out the same. 3.5 times 4 is 14, right? So if you just look at the initial problem, the only thing different between these two formulas right now is that we are multiplying by 4 here and an extra 3.5. Here, 4 times 3.5 is 14. Therefore, if I multiply by the same exact value, you should get the same answer.
I don't know how I got 175. Like I got the same thing you did for.
I purposely made it so it would be the same, so it
I don't
should
know
work
what
out
I
the
did.
same.
Maybe I punched it in wrong.
I'd say try plugging it in again.
Okay.
Maybe when you typed in the numbers, you rounded early or something. It's possible.
Okay.
Like,
Thank you.
yep. All right. So again, you get the same exact value. They should be equal. Therefore, it will not overflow. Again, if the volume is the same or less than the container, it won't overflow. If the volume was greater than the container, then it would overflow. Shh. Brian, what are you doing? Can you erase whatever it is you wrote? All right.
I wrote overflow because it's kind of.
Anyway, so those were the first two you guys asked for. The other two you guys asked for were 2 and 4. So let's look at those next, and then I'll go in order for the rest. So on number 2, It says the radius of the moon is about 1,080 miles. All right. The circumference of the Earth is approximately 3,963 miles. What is the volume of the moon? What is the volume of the Earth? So, on here. Now. Oof.
Mrs. Feedback, I entered the calculator.
And I'm wondering if hold on 1 second.
No, because her password is my password.
All right.
Wait, did she change it? Oh no, I don't want to. Yeah, I have it too. It's not right.
Volume of the moon. 4/3. Pi. R. Cube. Volume of the Earth.
What was that?
Now, is this the radius? That's the circumference. So, first you'd have to divide it. So, on here, this is really yep. Again, shh. How do you divide it in half first? Right? Oh no, wait. I think something's wrong here. I think Mr. Spizak has a mistake on this question. I think I printed out the old version of this review because I think I had this fixed. Yeah, no. Dang it. Hold on. Let me see something. Well, what do I want to do to fix this? All right, let's do this because I made a mistake. If you actually looked it up on your phone, this is actually supposed to be the radius of the Earth as well, not the circumference. Yeah. I mislabeled it. And I think I had fixed this on a newer version of this review, and I must have used the old version. Huh?
You did this? This isn't sort of like a textbook?
Yeah, no, I made this. Alright. So, yeah, because if you did this problem, it wouldn't make any sense because it'd show you that the Earth was smaller than the Moon. That wouldn't be right. So, I'll work it out so that you guys know what it is if you had used the other value. But I'll show it both ways. If you don't want to change your answer, you don't have to change your answer. Let me go through this the correct way first, and then I'll show you the screwed up answer. Yeah. So, again, what I just said was I screwed up. Yeah. So, because this was supposed to be the radius. It wasn't supposed to be this. Yeah, no. Because if you actually looked at these if you Googled these two numbers, those are the radius of the Earth and Moon.
Everyone did that diameter.
So I messed it up. All right, I will show you the answer if you use the other number though, because
Well, that still wouldn't be 3963.
Yeah, it's the diameter.
Because that would be the.
All
That
right.
would be. That still wouldn't be.
Radius of what?
That's not the radius.
all right. So let me show you the correct answer, and then I'll show you the other answer that you would have got if you used the work as it was shown. 1, 0, 8, 3.
Okay, I got an answer. What did you guys get?
Got an answer.
3 times 4 divided by.
She put them here? That's gay. Shit. Yes. Where's my username? No, I'm talking about first.
Why? You missed it.
Nope.
What does that say?
I'm having a heart attack. What the hell?
I got answers. I got it right.
That's the mood, right?
Yeah,
Oh, yeah, right.
Hold on 1 second. You can go back to that version on there still. I might be lost if they have a portion to use the new one because I can't figure out the editing on that one. The spicy part of
You
it.
can YouTube it.
Yeah, you can YouTube how to YouTube. Exactly. All right. All right, other part here. Sorry, guys. Let me make a little side note just so I know where I'm at in this video. All right. Anyway, multiply this out. Let's pick it back up where we left off. Sorry, guys. That's an important phone call. 4 times. Yeah. See it. 3, 9, 6, 3. To the third divided by 3 equals
When it says,
I look over and take this dollar. Bring out like a big
no!
all right. Those are the 2 correct answers. Now, if I had given you the correct version, that would have worked out nicely. And yeah, you can definitely see the Earth should be way more than the Moon. And if you check this, these numbers are pretty close to the accurate volume of each. Again, now, given the messed up thing that I had wrote on here, where I had given you the circumference instead of giving you the radius, your numbers would have worked out horribly wrong. So let's go and do volume of the Earth based on the value I gave you originally. If you had circumference,
Is this type of question going to be on the test? Good talk. Like, about that?
I don't think so. All right. So now, in order to get that down to the radius, you have had to divide by 2 and divide by pi, right? Because again, circumference is 2 pi r. So get rid of pi and 2, and you're left with r. So this keeps logging out on me. Divided by 2 divided by 2.14 gives you 631.05. And if you had used that to find the volume of Earth, $631.5 to the third, you've got a much different answer.
Speeds up, let's make a sense from art. I'm not gonna die.
What's that one program called where they give the
All right. Which you can see that makes absolutely no sense.
Really doesn't.
So, if you got that answer, of course the Earth is not almost a fifth the volume of the Moon. The Earth should be more like that one. All right. So again, this is the wrong one based on what was actually written on the review. If you fix it so that this is actually the radius, that would have been the correct answer, which makes sense. All right. 2, 4. Let's go to 4. All right. The pyramid. Now, this one is using similar solids. So, let me just mention this real quick. Remember scale factor, right? So, let's say for a second, scale factor is represented as A over B. All right? If we do area, it'd be A squared over B squared. If we had volume,
No, what did you get? We're not gonna make fun of you. What did you get?
it would be A cubed over B cubed. So, scale factor, area, volume. So, remember from before, scale factor is the ratio of any single dimensional measurement, right? Back when we did our similar figures before, right? Yeah, you'll see this on a test. So, all right. So again, scale factor, area, volume. Now, could you do these types of questions without doing this? Yes. Would it require a lot more work? Yeah. So on here, if you know the ratio of for the scale factor, which is going to be for any single dimensional object, the ratio of the areas of the object is just going to be the scale factor squared, and the ratio of the volumes is just going to be the scale factor cubed. So, on question number 5, it tells us that the pyramid at the, 4, I started reading the wrong one there. Number 4, the pyramid at the Luxor Casino in Las Vegas, Nevada, is similar to the Great Pyramid in Giza, Egypt. The areas with their bases can be written in a ratio of 64 to 100. What is the ratio of their heights and volumes? So, they're giving us this middle one. They're telling us that we have 64 over 100. How would you go backwards to get your scale factor then? Well, this is the scale factor squared. How do you unsquare something? Square root it. What's the square root of 64?
8.
What's the square root of 100? So scale factor for the heights would be 8 over 10.
Does that say AM?
For the volumes, again, it's our scale factor cubed, so now take 8 and cube it, and you get what?
8 times 8 times 8.
Yeah, what's 8 times 8 times 8?
512.
And 10 cubed? 1,000. Right. These are the two answers that they're looking for on number 4. So, all we did, if you, again, based on the scale factor for any figure, scale factor is single dimensional measurements. Area then is in square units. So, we'd have our units squared. So, same thing goes to our ratios. Our ratio is going to be the same thing as our scale factor was, just squared. Same thing for volume. Our volume is in cubic units because it's 3-dimensional. So our ratio is our scale factor cubed. So if they gave us the ratio of the areas to get the scale factor, we could go backwards and square root it because this is our scale factor squared currently. So we unsquared it, by square rooting it, and went backwards. Now that we know our scale factor, we cubed it to get the ratio of the volumes. That's it.
And how'd you get?
It's actually probably the easiest thing in this whole section.
60? Oh, so
But-
there's always going to be one that's just the same. That's easy.
So again, it's a matter of square rooting or squaring or cubing. Alright. So I did the ones you guys asked for. I'm going to go through the rest of these. Oh, look, hey, there's Cavalier's principle up at the very top. So, on this one, which of the following solids can be shown to have the same volume by using Cavalier's principle? Select all that apply. So, we have a hexagonal prism with cross-sectional area of B and a height H. Alright. The next one, a right cylinder with a cross-sectional area of B divided by 2. Well, right away, do those two go together? No. The cross-section is a different area. That doesn't work. On the next one, a square pyramid with a base of B and a height of H.
When I go to A,
Does that go with A?
oh,
No, why not?
well, it has the same cross section, I guess.
They wouldn't have the same cross sections all the way up. Yes, their base is the same, but again, a pyramid gets smaller as it goes to the top. A prism does not. So those two are not the same. On this one, a cone with a circular base of 2b. Again, different. That's already a different base. Those aren't. So none of these bases have been the same so far, right? Except for those two, and they're not the same. The last one, an oblique cylinder with a cross-section area of B and a height of. So this one and this one work. Those are the only two out of all those that work. Because they have the same cross-sectional area of B and they have a height of H. Those are the two things that you need in order to have Cavalier's principle work. Were they the same type of solid? No, one was a prism, one was a cylinder. But does that matter? No. Again, as long as the cross-sectional area is the same, it works. Alright. Okay. On 2 we already did. 3. You split an orange in half and measure the diameter is 4 centimeters. What is the volume of your half? So, what are we actually finding the volume of? A hemisphere. So, volume equals 2/3 pi r, which here was, is it 4? Is it 4? The radius? 2 cubed. Again, they gave us diameter, so the radius is half of that. The radius is only 2. So plug it in. Now we have 2 to the 3rd power, which is 8. But again, they said you're half. So we're only doing a hemisphere instead of a sphere. So you got to do half of it. So instead of 4/3, it'll be 2/3.
So we do 4/3 powers cubed and then divide that by 2.
Yeah, that's fine. Alright, so that's 8. 8 times 2 is 16. So we get, so far we're at 16 over 3 pi. This is not going to round to a nice number, but 2 to the 3rd was 8. Times 2 again is 16. And now we're still at 16 over 3, which again, once I do 16 over 3, it's going to be a rounded value. So that would be in terms of pi, or if we round this off, 16 divided by 3 times 3.14, 16.75. And this is in centimeters cubed.
Where'd you get 2/3?
The formula, again, for a sphere, it is 4/3. But again, this is only a hemisphere because it's half. So you had to divide it in half. Whether you want to divide it in half at the end, or whether you want to just do half the formula, both work.
Half the formula be 2 over 2.5? Wait, oh, never mind.
That's equivalent to doing the whole,
The whole equation divided by 2.
and then after you get that, you divide by 2.
Wait, say it one more. So what I'm saying is,
So you do,
if you did the other formula for a sphere, 4/3 pi r squared, and then took your final answer from that and divided by 2, you'd get this. Yes. All right. We did for 5. The pyramid at the Luxor Hotel Casino in Las Vegas, Nevada, has a square base that is that many meters long on each side. The height of the pyramid is this. To the nearest cubic meter, what is its volume? So, we know the dimensions of the base. We know the height of the pyramid. Do we need anything else? That's all the information we need. Volume formula for a pyramid is 1/3 base area times height. So we have 1/3 base area on this one, the square base. So again, that times itself is our base, 183 times 183. The height they gave us was 111. So 183 times 183 times 111 divided by 3. 1,239,039 meters cubed. All right. Go for it.
Oh yeah, after first period. Yeah.
183 times itself.
Because, again, base area, it's a square, so you could either say base times height or one side squared, but it's still that same number twice. Yeah, again, big B stands for area of the base, right? So you have to find area of the base, which is a square.
Oh, I got it.
So, again, this wasn't area of the base, this is just one side, right? Each side is 183. All right. On number 6, a girl has a pair of 14K solid gold ball earrings. Each earring weighs 1.5 grams and measures 0.6 centimeters in diameter. What is the density of 14 karat gold used to make the earrings? So, they're just asking us what the density is. Again, we just have to know our density formula. Density equals mass over volume. So, the mass on here, we have 1.5 grams. Volume, do we know what the volume is?
9.04.
How did you get that?
I did.
Why is the
4 divided by 3. 4 over 3 times pi r cubed. This is the sphere.
It's pi r cubed. So radius was 0.6 cubed.
0.3 because that's the diameter.
Oh, thank you. 0.3.
Yes, I
So we got
That's not even true.
3 to the third times 4 times 3.14 divided by 3. 113.04. Oh, wait. No. Sorry. 1 point. Shh, I didn't move my decimal. Hold on. So that should be 0.113, right? Not there. 0.11304. And that's our volume in. Wait. I thought you said it was 9 something.
Yeah, 9.04.
For what, buddy?
You divide the we do 4 over 3 times that. That's when I got 9. I had that number and 9 times by
Hold on. Did I not do that? Wait. Alright, let me redo it. Just double check since we got different numbers. Alright. So we had 0.3 raised to the third power times 3.14 times 4 divided by 3. Now I got the same thing. That's already multiplying the fraction. I think you multiplied your fraction twice. Alright, so this is our volume. So, now it's just division. We have 1.5 divided by 0.11304, and we get 13.2, let's round at 7 grams per cubic centimeter. Don't forget your units. Again, don't forget your units. There's a red tape dispenser somewhere in the room. I'm not sure where it is. I don't know. All right. Any other questions? No? All right. Number 7. A standard size NCAA women's basketball is about 9 inches in diameter. What is its volume? Leave your answer in terms of pi. So we need half that, right? So that'd be 4.5. This is in inches cubed. That's it. You good on that one? All right.
Let's just see.
On number 8. What's the volume of each of the figures below? Round the answer to the nearest tenth of a cubic centimeter. Now, I don't care what you use as the base on this. Again, I just want the final answer of volume. So, yeah. If you just want to do 6 times 4 times 3, that works. Again, and I'm going to plug it in like I'm doing my formula. Base area times height. I'm going to call 6 and 3 my base. 4 my height. Does it matter what order you multiply in? No. So it doesn't matter which one you called your base. Again, for a rectangular prism, that's the only one you can do that with. So 6 times 3 is 18. 18 times 4 is... And this is in cubic centimeters. On this one, again, they gave you more information than you need. Do you need the 7? No. Useless information. The 6 is our height of the rectangle, height of the triangle. 4 is the base of the triangle. 12 is the height of the solid. So again, if you plug this in, we have volume equals base area times height, which is 1/2 4 times 6 times 12. So 1/2 of 4 is 2. 2 times 6 is 12. 12 times 12 is... On this one, 10 and 5 are the only 2 dimensions we need. Again, volume for this one, base area times height. Base area for this time, pi r squared. Radius is 5. Height is 10. 5 squared is 25. 25 times 10 is 250. So we can either say 250 pi, or if we multiply that one out, I can't do that one in my head. 250 times 3.14. So you can say either 250 pi centimeters cubed, or the approximation 758 pi.
85.
What did I say? 785. I wrote it right. I said it wrong. All right.
My bad.
On this one, again, this is a hemisphere. So again, 2/3 pi r cubed. If you wanted to use 4/3 pi r cubed and then divide by 2 at the end, that's fine. Does the same thing. So 2/3 pi, radius is 9 cubed. So we got 9 cubed. Yeah, 729 times 2 divided by 3.
That's going to be 1,526.04.
And that's after you multiplied by pi, right? So again, exact answer, rounded answer. It's saying, oh, it did say nearest 10th. You're right. So really, you don't need any of that. And then if you were to, again, this is also in centimeters cubed, centimeters cubed. Now, I know you guys would love to have the whole test be just these. Right? But just doing problems like this
It's good.
is not geometry in high school. These shapes plug into the formulas that we just did. This part, you guys have been able to do for longer than just this school year.
Are you guys going to add extra credit?
Or should have been able to do longer than this school year. So your test is not just this straightforward volume. I'm sorry.
I understand, but like, given the previous test scores, can you go a little bit like,
Am I going to make it?
go to below what you think is gonna break it apart? Okay, like, honestly.
Can you at least give us extra?
I gotta also have my. I also have to have my department head approve the test. I can't make it that easy.
Can you
Sorry.
give us like an extra credit that's kind of easy?
We can put extra credit on this test.
Yeah, that silo question was
How are we
full.
supposed to know that silos are made? Okay, I didn't even answer that.
I got.
I gave you a picture of the silo.
I know. I didn't know it was underground. I did it myself.
Underground.
Part of it is in
I
the
got
ground.
-3 though.
No, on the ground, the bottom.
Oh yeah.
I'm
Yeah.
pretty sure. I got just as many. I didn't think I had to.
All right. Anyway,
My test.
on here, number 9. All right.
Doing the silo.
A cone
I was.
has a height of 13 feet and a diameter of 24 feet. To the nearest hundredth of a square foot, what is the lateral area of a cone? Now, again, am I going to ask you a direct question like this on the test about lateral area? Probably not. Could you have to use lateral area on the test or surface area on the test? Yes. Again, you got to keep that in mind. There's probably going to be at least one question that uses something about surface area or lateral area on the test. All right. Now, a cone has a height of 13, diameter. So, okay, what we need for lateral area,
Then 1/2 feet up.
this is just going to be, you could do it one of two ways. 1/2 circumference times height, or pi r L. Both of those work. We don't have a slant height. We don't have a slant height. But what we do have,
What is that? C? Thank you.
what we do have is the height. We have the diameter of the circle, which half of that is. So we need the slant height. Now, this is not a Pythagorean triple this time. You'd have to do Pythagorean theorem for this one. Because you have 12, you have 13, you have to plug those in, take the square root. If you use Pythagorean theorem on this one, see, square root of 13 squared plus it's gonna be 17.6918 for the radius.
17.
Again, I would keep a couple extra decimals until the end. All right. If you want to keep the number in your calculator until you use it, that's fine too. So we have pi times that number squared. Whoops. Sorry. No, not number squared. My bad. I wrote that a little early. The radius. Where did my thing go?
Wait, squared?
No. Sorry. I looked at the wrong number for a second. The radius is 12. That's what's squared. Times the 17.6918. Whatever. So, alright. Pi 12 squared times 17.6918. So again, plugging that whole thing into the calculator. Times, again, it said use 3.14 for pi. That'd be and what did it say to round to?
7,000?
Nearest hundredth. So
Is that 9?
it'll just be 53.
Is that 999? I like this one. Is that 7,999?
7,999.53 feet squared.
That was like an H.
Well, it looks like an H.
I didn't know that was
Better.
So when the test is officially going to be on Wednesday?
Next Wednesday.
Yeah.
As of right now, I think that's still fine. We did 10, we did 11. That's all.
Thank you, sir.
Yeah.
I hope you're